All right, welcome everyone. Thanks for joining our session today on tracking data and AI lineage to ensure transparency and compliance within your organization. Your speakers for today, you have me. My name is Murt. I'm a product manager here on our Unity Catalog team. I look after lineage and access control. And with me, I have Prithvi. Prithvi is an engineer on our machine learning team here, and we'll be talking about data and AI lineage. Awesome. Before we get started, just standard disclaimer, the features that we talk about today may change slightly in nature before they hit your laptops. All right, so we have a packed agenda today. We'll start out by giving you a quick overview of Lineage and Unity Catalog. We'll then dive into our roadmap and upcoming launches that we're super excited about. Then we'll be talking a little bit about Lineage for AI and how we're thinking about the importance of Lineage in ML development workflows. And then we'll talk a little bit about our Lineage system tables to get additional insights in Databricks. And as always, we'll be doing a bunch of live demos, hopefully, so looking forward to that. All right, so before we dive into Lineage and Unity Catalog, just want to talk about why data lineage is important and how we see it within Databricks. So we think data lineage is really important for three main uses. The first is probably the one y'all are most familiar with, which is compliance. So whenever an auditor comes and asks you, where did this data come from and where has it flown in your organization, Lineage helps you kind of track this spread of data down to the field level and see, especially when it comes to sensitive information, where potential sensitive data or PII may have entered into various data assets. The second piece that we think Lineage is really, really useful for is for data discovery. So Lineage can be a tool where users can understand the context of their data, find which upstream sources it came from, where it's being consumed downstream in production dashboards and other people's queries, which are all gives trust signals for users looking to use a particular data set for their analytics or data science use cases. And the third piece, which we think Lineage is super important for, is for impact analysis. So anytime you have pipeline failures upstream, data quality issues, things like deprecations, you want to be able to track that impact all the way downstream, not just in derived data sets, but also in queries, notebooks, dashboards that users may have set up on top of your tables. And so we think you can kind of track the impact of these failures downstream. And then similarly, helps you do kind of root cause analysis. You may have a data quality issue downstream, which was propagated from some stale or incomplete data upstream. So these are kind of the three main pillars of why we think data lineage is super important. So a quick overview of data lineage in Unity Catalog. Three things you need to know. Number one, it's auto-captured at runtime down to the column level and for all your read and write events against Unity Catalog-enabled compute. So as long as you're using a UC cluster, anytime you do any kind of operation which reads a table, writes to a table, we'll be capturing that automatically. Number two, we support queries in all languages. So not just SQL, but if you're doing things in Python, R, or Scala, we automatically capture for all those queries at runtime. And then lastly, we think this is the most important bit about Lineage and Unity Catalog. It's not just for your data assets, but also for your AI assets. So traditionally, most other Lineage services kind of have your typical tables and show you relationships between tables, views, and then the workflows that generated them. We're really proud about Lineage and Unity Catalog, where it covers all your AI assets. So things like volumes, where you would store unstructured data, then also for models. So if you're training them, doing inference of them downstream, we capture all of those things, which we'll talk a little bit more about a little bit later. And also all your kind of non-UC governed assets that may live in your workspace, things like dashboards, workflows, notebooks, all of these kind of are captured within our Lineage capability. And then we're also including federated sources. So if you're federating from other database management systems, we show this lineage downstream in Unity as well. And so you can see a lineage graph here, and it kind of shows all the various types of assets, tables, volumes, models, dashboards, views, federated assets in this lineage view. And you'll notice there's some external data assets also as part of this, which we'll talk a little bit more about with our Bring Your Own Lineage feature later in this talk. All right, so what's new? One of the things we're super excited about is data quality monitoring. So this is a feature that's now in beta, so you can find it in your workspace already. And data quality monitoring, essentially what we do is we will scan all your tables once you enable it at the schema level for freshness and completeness. And we kind of propagate this little dot icon everywhere in your catalog explorer and in your various Databricks surfaces, which gives you an indication on what the health of this table is. This is super important when it comes to lineage because we're coming soon is data quality monitoring being integrated with our lineage service. So you can kind of get a view of where quality issues occurred upstream. So for example, if you've enabled data quality monitoring and a pipeline doesn't completely run and now you have incomplete data, you can go into your lineage graph, find a quality issue, find which upstream data source had this problem, and then figure out what the downstream impact of this will be. So we're super excited about data quality monitoring coming soon in Lineage to power root cause and impact analysis in Unity Catalog. So we talk a lot about Lineage within Databricks and within Unity Catalog, but we obviously understand the flow of your data doesn't start or stop in Databricks. So you may have data being ingested from upstream sources, ERPs, CRMs, operational databases, maybe some Kafka streams, and then this data comes into your bronze layer and then is ETL'd, and then eventually it may be consumed even outside of Databricks in external tools. So think BI tools like Looker, Tableau, Power BI, or in downstream custom apps where you're querying this data. And one of the things we want to really make it easy for you to do is have that full source of truth for how your data is flowing in your organizations, all within Unity Catalog. So we're super excited to tell you about Bring Your Own Lineage, which is a feature that's coming into public preview later this month. And there's basically two main use cases that we see for it. One is you can kind of annotate what your upstream first mile lineage, as we call it. So prior to data entering your bronze layer, where it came from, you'll be able to kind of add in this metadata on potentially it hopped through multiple source systems. Maybe it went to a cloud provider where you were doing some kind of ETL and then it came into UC. And then similarly on the last mile side of things, we know a lot of you kind of consume your Unity Catalog data in your dashboarding or reporting tool of your choice. We want to make it really easy to add in this additional last mile context into UC lineage. So that way, whenever your users go into the lineage graph, they can see that potential, if they make a schema change to a table, it could break some downstream report that's outside of Databricks. And so we make this super easy, and I'm going to do a quick demo on how Bring Your Own Lineage will work in Databricks. So I'm going to switch over to my Databricks workspace here. And so I'm in the Catalog Explorer here. And there's two steps to adding custom lineage within Unity Catalog. The first is we've introduced a new type of securable in UC to hold metadata specifically to be used in custom lineage. So when I navigate to the External Data tab, there's a new subtab called External Metadata. So external metadata objects are essentially a way to represent things like tables, dashboards, reports in external systems within Unity Catalog. And you can add in certain metadata for these assets. So you can give it a name, select the system type of this asset, the entity type, whether it's dashboard, table, etc. Descriptions, you can specify the columns that are present in that object, any other additional properties. And once you've created this, let me go to an example one. So I have a external metadata object that represents a Salesforce accounts object. And once I've defined this in Unity Catalog, I can create a lineage relationship based on it. So I'm going to create a custom lineage relationship where I'm saying the Salesforce object is upstream of one of my sales data sets. And then I can even do kind of column level lineage specifications to show like which fields map to which things. So whenever my consumers go into the lineage graph, they'll kind of see this in the same way as they would our auto-captured lineage. I'm just going to put something in here, create. Got some failure, but let's see if it's still showing up. And in the lineage graph, this will show up similar to the auto-captured lineage, where you can kind of see here's the relationships to this table and where it's being consumed downstream. And similarly, you can do this for not only your upstream asset types, you can specify multiple levels of upstream data sources. You can also do kind of downstream. So you see there's like a Tableau dashboard here that's based on this table, and it'll have the metadata that's been added in. All right, cool. Let me go back to the slideshow. And so we're launching Bring Your Own Lineage in public preview later this month. And beyond the public preview, we have some additional things that we're currently working on. So one of the things that we're super excited for is, you must have heard in the keynote earlier today, our GA of Lakeflow. And as part of the Lakeflow suite of products, we have our Lakeflow managed connectors. And so if you use one of our Lakeflow managed connectors to ingest data from the supported data sources, we'll automatically capture this first mile lineage, and we'll create these external metadata objects and link them in your lineage graph, so you don't have to go back and add them in via the UI or API after the fact. We'll also be working on adding custom lineage to our system tables. So we'll talk a little bit about our lineage system tables later on in this talk, but any kind of lineage that you add in through this Bring Your Own Lineage feature will also be there for querying programmatically. And then lastly, we're looking at our North Star is to have these kind of connectors and crawlers to all the common systems that customers have data coming from and flowing to. And so then you'd just be able to kind of, for example, if you have a bunch of Tableau dashboards that are reading from Unity catalog tables, you can just give us your auth, and we'll be able to kind of crawl your Tableau instance and make those lineage connections. And that way, whenever consumers go in to look at your tables in Unity catalog, they can see here's all the downstream reports and dashboards that are depending on it. So when you're making things like schema changes, or there's data quality issues, you know kind of the full downstream impact picture, not only in Databricks, but in external systems as well. All right, I'll hand it over to Prithvi to talk a little bit about lineage and AI development.
Thanks, Murt. So yeah, there's a lot of great features in Unity Catalog for lineage, but let's talk about how we can apply these to the AI development workflows that we know are ever more popular today. So the first part that's really important is what happens when you create a new model. Typically, you have to do some sort of training, and that involves a training data set. And so it's really important to understand what training data set is associated with one particular model version. So for example, if I took a data set and I scrubbed it heavily, then I might get very good eval results. But I did that because I changed the data set, and then I can't compare that model's results with the results from a previous iteration of that model that was trained on a different version of the data set. So this is super important, and Unity Catalog provides this right out of the box for us. And this is one of the things we're really excited about. The next piece of the training data set that I think is really important is understanding which sensitive fields were used in the training. This is really important for auditing purposes. For example, a customer may be looking at a series of data from their customers, but then customers eventually will be able to opt out of their training data being used. And then we need to know that, oh, customer A's training data was being used in this model. They're no longer, our terms of service with them are no longer allowing us to do so. We need to be able to remove this data. So lineage allows us the ability to see where the data came from, if any of this data is sensitive, and allow us to take the right action on that. The next piece that's really cool is once you take this model and you decide that this is ready and you want to do something with it on Databricks, typically people serve their models. And if you do model serving on Databricks, we have end-to-end lineage to show you where this model is being served. So in many organizations, they have data scientists who are pushing the models, new versions of the models into the Unity catalog, and then they have a machine learning engineering team or a deployment team that's basically responsible for setting up some of the serving infrastructure. And so if you're a new data scientist and you're going to push a new version of the model, you can help answer the question of which applications are serving a previous version of the model, how do you communicate that update to this team, and let them know that a new version of this model has arrived. The last piece that's really interesting is tracking model performance through lineage. So we all know that basically the model is only as good as the training data, but sometimes your model can have really good performance in your training data set and then really poor performance when you deploy it in front of your customers. So it's really important to know as early as possible that you're in that situation and maybe revert back to a previous version or make any necessary modifications. So Lineage helps us answer this question through the inference table from the model serving product. We'll talk a little bit more about this in the demo in a couple minutes, but basically all inputs and outputs of your serving endpoint are captured into an inference table, and you can run a monitoring workload on that and evaluate the same quality that you would have done in your offline evaluations for production data. And so if you have a model that's predicting fraud, for example, and that in the training data set was predicting fraud at 1%, for example, but then when you deploy it into production, you start predicting fraud at 10%, the monitoring workload would help you identify this gap, and you'd use Lineage to see this whole end-to-end process and understand how your model performance has diverged, and then maybe you need to take action accordingly. So this lineage is mostly auto-captured on the product. So if you have upstream data sets for the model training, these are all automatically captured within Databricks, as well as feature tables and functions that are used when training the model version. And the downstream assets of the model lineage is also captured. So the serving endpoints that you're using to power this model when you're serving it in your apps, as well as the inference tables and the downstream data that's being created by these models are all auto-captured on the platform. So now I'm going to jump into a demo where we're going to talk about what it means to train some of these models. So we're going to start in a notebook here, and what we're going to do is we're going to work off the taxi training data set. So this is a pretty classic machine learning problem. We're going to try to predict the taxi fare price, give it a bunch of features like the distance and the time of day. This is a public data set from the New York City taxi data set record. So what we're going to do is find this data set on Databricks. So in Databricks, we put it in this catalog. I have a taxi data set here. And what we're going to do is we've already annotated the upstream lineage piece. So if we go ahead and open this data set here, this is my catalog prod default taxi data set, which has the data. And I've already annotated this as coming from this New York City Gov data set. This is an external metadata first mile lineage that my colleague Murt just presented about. So once we've made this association between these two data sources, we can go ahead and start training our data. So what I'm going to do is I'm going to first open up this data set, my taxi data set, and let's take a look at it. And one of the things I noticed in my data set is that sometimes the fare amount can be really high. For example, we can't see any examples here, but I did some data science earlier, and I found out that there are a lot of really large fare amounts. Maybe there was some extraneous circumstances, or sometimes the fare amount is just zero. Basically, this data set is not cleaned in the way that I would have expected it to be. So I went ahead and created a taxi data set cleaned version, and we're going to go ahead and train models on this version. So my teammate might come up to me later and ask me, how did you clean this data set? So just to demonstrate a little bit about that process, we can open the lineage graph, and we can see the relationship between the taxi data set and the cleaned version of it. It's linked by this edge here, and if you open the query that's linked, we'll see that all I did was select from the original data set for all the examples where the fare amount is within 3 standard deviations of the average. So that's just what I did to do my data cleaning, and now I'm ready to do my ML modeling. So we'll jump into a notebook, and today I'm going to use MLflow. We just launched MLflow 3.0 yesterday, so we'll be using the latest and greatest features from MLflow. If you're interested in this more, feel free to check out the mlflow.org page, and you can learn a little bit more about how the system works. But for now, we'll just jump right into the code. So I'm going to pip install MLflow. I'm going to start my session, and then I'm going to train this model. We'll go through the model training code very briefly. Basically, what I'm going to do is I'm going to load the data set from Unity Catalog. I'm going to go ahead and select the fields that I care about. So the fare amount, that's the kind of prediction value. And then the inputs are trip distance, pickup zip code, drop-off zip code, and the time. We're going to go ahead and use a scikit-learn linear regression model. Just do a really simple model.fit call. And then we're going to calculate mean squared error and log this model to MLflow. When we log this model to MLflow, we're basically packaging up this model with all the weights that are trained here, and then we're going to keep all this record about this model. So we'll go ahead and run this. And while the model is training, the really important piece we want to show here is that the data set that this model was trained on is the clean data set, and that we should not compare the results from the clean data set with the other data set. Okay, and in classic lab demo fashion, we got an error. Let me just rerun this. Input X contains NaN. Let me take my Databricks assistant suggestion. All right, so my model training doesn't work today, but that's okay. I have something prepared for us. So we'll just go back and take a look here. So in my MLflow experiments, I can see the taxi training that I did a little while earlier. And basically, you can see that there's this model that I just trained, and it was trained on this catalog prod taxi dataset clean. And we see that this model and this dataset are basically linked together in this way. If you click on this go to table, you'll go right back to the Unity catalog table. And the thing that's really interesting is that we can see that the training data is actually associated with a certain model version. And so we know that this version was trained on the clean data set, and another version was trained on the raw data set. But let's say we like this version, and we want to go now register it to Unity Catalog. So all we have to do is type in mlflow.register model, and we have this model registered in Unity Catalog. And when you register this model to Unity Catalog, all the training data and all of the lineage from the training process is automatically pushed into the lineage graph. So let's go ahead and open the lineage graph for this model. This is version 4. This is the one that I just did set up right before the demo. And you can see that it was trained on the clean data set. And we can trace this lineage graph all the way back from the clean data set to the original data set, all the way back to the NYC Gov, the source of all this training data. So this is really neat and really important. It provides the end-to-end story. And let's say now I think that my model is ready to be served, and I'm happy with the results of it. I'll go ahead to the model serving tab here and go to my taxi test data set, and I will select version 4 to serve. And when I'm in the serving endpoint, I'm going to hook up an inference table called taxi test payload that will capture the inputs and outputs of each request. We can go ahead and fire a request into this model and see if it works. So we try out a certain combination of pickup zip code, trip distance, etc., and we get a prediction, $12. Let's put something large, maybe 20 miles for the distance, and we see it's going to be $60. So this is really neat. We can have a model that works. But let's talk about the lineage now. So when we go back to the catalog and we take a look at this model, we can now see that the inference table, this is the table that's going to store all the inputs and outputs for the model, now has a link back to the model itself. So we can see that, oh, sorry, I clicked the wrong table. The payload table, if we open the lineage tab here, we will see that there's the payload table as well as the upstream model. And you can see that for various models, they all got written to the same payload table, so we can compare the different results from the different models. And now we have this full end-to-end graph. So if we expand it all the way back, we now have, from one end of the chart, we have this NYC Gov data set, we have the raw data set, the clean data set, the model, and then the inference table. And now if we're then notified, maybe using the data quality monitoring and other techniques, that our prod data has been compromised or that our prod data is showing poor model drift, then we know basically where the source of this is, and we can go back up the chain and trace the origin of this data. So the last piece that I think is really neat here is you can build really rich visualizations over the payload data. So maybe I have some, like my executives are interested in how much usage is going through my AI system. That's the talk of AI nowadays. People are making a lot of demos, but how many of them are actually making it into production? How many customers are actually using them? So maybe I will create a Power BI visualization for my executive. And let's go ahead and show, let's pretend that I already made this visualization, and let's just link it into the payload table. So we can go back to the catalog and go to the external data. And let me go ahead and associate this account insights report with our inference table. So we will say that this is an upstream relationship with the table, and this is the payload table. And I'll go ahead and say select. And now when we open the lineage graph, we can see that actually we have this end result, like Tableau dashboard, that we can show to our executives, which is using this payload table. So all in here, basically with just a few clicks, primarily auto-captured metadata, we can see an end-to-end journey of all this model training. And it's really rich data set that's going to be really powerful as you move your model through production and eventually start to deploy out later versions of this model. Cool.
All right, thanks, Prithvi. So we're going to switch gears a little bit and talk a little bit about our lineage system tables. So we recently made these generally available, so these are available to everyone. And there's three things we want to highlight about our lineage system tables. So number one, there's two different system tables, one for table level lineage and another for column level lineage. And they record each read or write operation that users perform in Unity Catalog in these tables. So in many ways, they're kind of an audit table because it has all these records. And so you can get a lot of great insights from these tables, not only in lineage, but other things in your data state. And the two main use cases that we've seen folks use these system tables for is number one, to get a lot of usage insights. So because this has kind of every read or write operation against these UC tables and columns being recorded, you can kind of figure out what are the highest usage data sets in your data state, what are the unused tables, unused columns that you may want to deprecate to prevent a data swarm. All of these insights can be captured through programmatically querying these lineage records. And then the other piece that we think it's super beneficial for is for impact analysis. So obviously the lineage graph is super useful for kind of navigating and seeing how things visually are related, but you may just want to kind of run a report which says, we're deprecating this table. What are all the downstream derived data sets, views, dashboards, queries, notebooks? Who are the owners of these assets? And in order to alert them for this kind of deprecation notice or maybe a schema change that will break things downstream. So you can kind of quickly get these insights through the lineage system table. One of the pain points we've heard from customers is that they don't know kind of the types of queries that they should be running against these kind of system tables, which is why we've recently entered into private preview with a set of out-of-the-box dashboards that are powered by these lineage system tables, which help you kind of address these most common use cases, like doing impact analysis or getting insights into usage of specific fields from your production data sets. So I'm going to go ahead and switch back over to do a quick demo, actually, on these dashboards. So the first one I'm going to focus on is this impact analysis dashboard, which is based on our system table, which you can import today as part of our private preview. And the way this works is you can just specify a table name or a path that's been registered to Unity Catalog, a date range, a lineage depth, and a direction, and kind of get a report that tells you, here's all the downstream assets in that direction, who last modified them, what's the depth of the relationship, so not just like the first degree, but multiple degrees downstream as well. You can see what are the other like non-data assets, so things like notebooks or queries or dashboards that are based on these tables, and see kind of the distribution of depth in those, see things like the usage over time of that particular table you're looking at. And what's really cool about these dashboards is they kind of get imported in your workspace as regular AI BI dashboards, so you can kind of go ahead and also see the kinds of queries that we're running against these, and you can modify these and kind of get a sense of how you should be potentially looking at querying these tables as well. And so that's our impact analysis dashboard. Another dashboard that we have as part of these insights dashboards is around Unity Catalog usage. So you may want to kind of just get high-level insights into kind of what are the most used data assets. And Lineage is really good for this because the system tables record each read and write operation. And so you can do things like filter by a catalog, see what are the most used schemas, see what are the most used tables within those. So you can see like the attributions table in our marketing.silver schema is the most queried. You can kind of delineate by read operations versus write operations on tables, date ranges for when these operations are run, which users or service principals are running these operations. And then based on that, you can get like insights around how many high usage tables you have in your data estate, or how many unused tables, so tables that are being written to but don't have any read operations downstream of them. And so you can kind of consider deprecating those assets or contacting those data owners of those to let them know that there's potential data swamp issue. And then similarly with your most used tables, you can kind of track down, are these being, is there good metadata around it? Are they discoverable for users? Things like that as well. So a lot of great usage insights that we think folks can get from these system tables. And these out-of-the-box dashboards similarly allow you to kind of see the kinds of queries that you can run against them and then modify them and get inspiration to run kind of your own kind of analytics on top of them. All right, so we're just wrapping up here. So a few things to take away. We talked about a lot of different things in this talk. 3 key things that, to summarize. Number 1, Lineage and Unity Catalog covers all your data and AI assets. It's auto-captured at runtime, and all of it will populate in your Lineage graph and also in your system tables for programmatic access. Number 2, our new Bring Your Own Lineage capability that we are launching into public preview later this month will allow you to make Unity Catalog the source of truth for end-to-end data flows in your organization. So through the new external metadata object in UC, you can kind of catalog external objects and external systems and use those to add custom lineage. And then number 3, we think the lineage system tables are super, super powerful and should be leveraged for getting additional insights around usage, lack of usage, and then doing things like impact analysis to report on changes like deprecations and quality issues. All right, before you head out, don't forget to complete your survey to give us feedback on the summit. And you can scan this QR code to continue your learning journey with all the different trainings and certifications that we have at Summit. Thank you, everyone.